Hello and welcome to Angles of Elevation and Depression. We're going to look at word problems that can be solved using trigonometry. Now the thing about these problems, they're all pretty silly because they're all happen in this like magic fantasy math land where everything works out perfectly. Like everything is completely straight. There's no hills, there's no valleys, every line is completely straight. And you have all these situations of these people that are standing someplace far away from something, and then they look up at an angle of elevation, which means like they have like no height. They're like flat on the ground, maybe laying down, looking up, and then they reach into their pocket and they pull out a protractor and a laser pointer, because everybody carries those with them. And you can tell and look and say, okay, I can line up to see where that airplane is, and I can look at my protractor, and it's absolutely perfect, and I can get my mathematical degree, and I'm probably a cyclops too, because I don't have to worry about which eye to close whenever I'm looking at it, so I only need one eye laying flat on the ground, and then whip out my calculator, find the tangent of whatever it is, and be able to solve it. All these problems work out in this kind of hypothetical reality that's not really real, but we're just going to assume that all these things are just like perfect, so that our triangles work out perfectly. The two things that you need to know as far as words go are angle of elevation and angle of depression. Angle of elevation always means the angle above the horizontal. So just like I was talking about, if you're laying flat on the ground and you look up, the angle between the horizontal and where you're going up, that angle is an angle of elevation. It's the amount above the horizontal. The angle of depression is always if you take the horizontal and then you go below it. So it's this angle here, and that's one that people make mistakes on a lot. But you almost have to think like people are flying in an airplane and somehow somebody's hanging them out of the airplane so they can measure this thing with their protractor. But they have to look at what's the horizontal and then what's the amount below that to be able to find the angle of depression. Okay? So you can pause the video to write down this example. There's a lot of words here, so you can pause it if you want. You should probably pause it here, and then we'll work it out. Here we go. Angie looks up at 25 degrees. So again, here's Angie. We're going to pretend that she has 0 height. Here's the ground. She looks up at 25 degrees. Whoop, 25 degrees. And she sees an airplane. Oh, I'm terrible at drawing airplanes. Okay, let's see. Something like this. Yeah. My airplanes always look like fish. I don't know. Sort of close. It's flying towards her. The plane is flying at an altitude of, altitude means height, of 3.5 miles. How far is it from being directly above Angie? Oh, so that means that if this plane's going to keep flying here, flying straight, we want to know how far is this? Boom. So that when you look up and say, there it is, we want to know how far it is from here to here. Well, that's the same thing as from here to here, right? So let's look at this triangle here. Okay. So this is my angle of reference. This side is called the class. This is called the opposite. And this one is the
adjacent.
Adjacent. Good job. Okay, so we've got opposite and adjacent, and we know that is tangent. So tangent of 25, only talk what I tell you to, is 3.5 over the adjacent. Oh, this is one where the variable's in the denominator. We have learned how to deal with that, right? Who knows how to deal with that? What do you do? Multiply by x, very good. We'll go times x times x. So I've got x times tangent of 25 equals 3.5. Now to get x by itself, divide by tangent of 25. So 3.5 divided by tangent 25. I don't have a calculator up here. Hold on. Somebody help. 3.5 divided by tangent 25. 7.5? 0. Okay. So he's 7.5 miles away before he's directly above. Okay? Next problem to copy down. Lauren is at the top of a 15-meter lookout tower. I don't know why she's there, but she's there, looking out. From an angle of depression of 25 degrees, Okay, so we got lookout tower. Drawing a tower. I don't know. We'll just call that the tower. Here's Lauren looking out from an angle of depression. She sees Evan. Hi, Evan. Here we are. Hi, Lauren. Now, when she looks down, what we have to consider here is that the angle of depression is not here. This is not the angle of depression. The angle of depression is below the horizontal. So you have to think, here was the horizontal. Here's where she's looking. This one is 25 degrees. That's the most common mistake, is people will say this is 25. But the angle of depression is the amount below the horizontal. So let's make our little triangle here. And she's 15 meters high, which means this triangle is 15 over here. How far from Evan is Evan from the base of the tower? We could do this a couple different ways. We could look at this triangle and find that, or we could subtract, if you wanted this whole thing together, is 90, so this would be 65 degrees. I'd probably prefer to do it that way. Let's make this 65 degrees, because together they make a right angle, and what we're trying to find is how far from Lauren's tower to Evan. Okay, so here is my angle of reference. This is the opposite. This is the adjacent. Again, we got tangent. Tangent of 65 equals the opposite over the adjacent. But this time, the x is in the numerator, so it's a whole lot easier. All I need to do is multiply by 15 and by 15. So I got 15 times tangent 65 equals x. I need some calculator friends. 32.16. 32.16. Okay, so that's how far this is down here. Goody. Next one. You can pause the video if you need to copy this down. A 6-foot vertical pole casts a shadow of 11 feet. That's kind of weird. It's only a 6-foot vertical pole. We'll say here's my pole. But it makes a shadow of 11 feet. It's a little longer. Oops. Which means we probably have the sun over here. It's probably getting ready to set. Makes a long shadow. What is the angle of elevation with the ground? Okay, so we're looking for x. What is the angle above the horizontal? Well, this is the opposite. This is the adjacent. Tangent again. We use tangent a lot. So tangent of something something equals the opposite over adjacent. Now, if I know that the tangent of an angle is something something, then if I take the inverse tangent of both sides, I have an equation that says this. Inverse tangent of 6 divided by 11. Calculator friends, the calculator will do this for me and tell me that angle, and that is
28.2 or 6.
28.661. And that is degrees. So that tells me that this angle is an angle of elevation of 28.61 degrees. Thank you, calculator friends, all of you. Last one. A man is standing on top of a 200-foot cliff. Okay, look out. Whoa. Woo. Hope there's a railing. 200-foot cliff. And he spots a boat out in the sea. Hey, look what I see. Oh, that's a terrible boat. I can't draw at all, but the pictures are really helpful still. Yeah, here's my little sailboat. Hi. What are you doing up there? Go away. The angle of depression from the man to the boat is 12. Now, the problem people will make is they'll go, okay, 12. Wrong. It's the angle of depression is below the horizontal. This is 12, which means this is 90 minus 12, which is 78. Yeah? 78. And I want to know how far until the boat crashes. So I'll use my angle of reference here, 78. And we've got opposite and adjacent. Again, tangent. I can't help it. Too much tangent. Tangent 78 equals opposite over adjacent. But this is an easy one because the variable is in the numerator. So we'll go times 200 times 200 And we got tangent of 78 times 200 equals x. So how far away until he crashes? Negative? That's a problem.
Pretty sure it was.
Do 200 first, then times tangent 78. 940. Oh wait, 940? Yeah, we're not going to be negative. 940.9. All right, so he's still got some room before he crashes. Okay, so this is the way you set up. The pictures are very important. Angle of elevation, angle of depression. Draw them out and label your sides and use trigonometry. Have a great day.